You know what? We can turn this into a drinking game. Every time you don't answer my simple questions, we all take a shot. That would be so much fun, wouldn't it? For about 5 minutes. Okay. Let's take the natural log of some other numbers. Alright, so the natural log of... Denise, what's your favorite number? 7. That's a great one. It's that. Is it everything you hoped and dreamed it would be, Denise? Yeah? Oh yeah, of course. Who else has a favorite number? Keyshawn, what's your favorite number? 3.42? Okay. Strange. There you go. Pamela, what's your favorite number? I can't hear you. What? 1/4. Okay. Seriously, I mean, like, how much more we gotta do? You can take the natural log of any number using the calculator, right? Okay, so we've now reached a point, thank you to Texas Instruments. We can take the common log of any number, and we can take the natural log of any number, right? So if we go back to this problem, the calculator still doesn't help us with any of these guys, right? Because the calculator doesn't have log base 5. It doesn't have log base 7, and it certainly doesn't have log base 5.281604. I've been petitioning them to put one on there for a long time, and they aren't replying to my email, so I don't know when we're going to get it. Okay? So we need some other way of getting there. Thankfully, we have something. We have what we call a change of base formula. And we're going to use this formula to get the calculator to do all those quirky little logs that we couldn't figure out in our head. Because remember, only 2 of you knew that 7 to the 3rd power was 343. I'm just astonished that 2 of you knew that, actually, to tell the truth. Most people don't have their powers of 7 memorized up beyond, say, 7 squared. Right? So change of base goes like this. Let's call this the log base b. And b can be anything. Any number that it's allowed to be. Like, it can't be negative, it can't be 1, it can't be 0, but log base any other number of, let's just call it like a capital N. Okay? It's something that I'm trying to take the log of, though. It turns out that this logarithm here, and I'm going to show you why, is equivalent to the common log of m, the number that I'm trying to take the log of anyway, divided by the common log of your base. Which is also equivalent to the natural log of whatever that number is, divided by the natural log of your base. And this change of base formula is going to be the thing that lets you take the log of any number of any base on the test with the help of your calculator. Okay? And I'll give you the formula, and you can have a calculator, so you've got no excuse for missing it. Alright? Now, here's the proof. You don't have to memorize this. You don't have to write this down unless you really, really want to, because you think this is all fascinating stuff. But I want to show you where this comes from. This isn't just magic, hey, it would be a whole lot easier to work this problem if I could do this. Like, there's a reason we're allowed to do it. Okay? So let's suppose that y was this log base b of our number m. Okay? That's me a log equation. Okay? But what if I took that log equation and I rewrote it in exponential form? Remember doing that? You start with the base. What's my base? B. And out of the remaining 2 numbers, which one was my exponent? The y was my exponent, right? This is b to the y power is going to equal whatever that m is. Okay. And then from day 1 of working with equations, our our cardinal rule working with equations was you can do anything you want to one side of the equation so long as do the same thing to the other side, right? So what I'm going to do is I'm going to take the common log of both sides. All right, so I'm going to have the common log of b to the y equals the common log of m. All right, well, because I've taken the log on the left, that's me taking the log of something with an exponent, right? And what do I get to do with that exponent because I have a log now? I get to bring it up front, right? So this is the same thing as y times the common log of b equals the common log of m. And you know what? If I wanted to get this y by itself, I could. What would I do? Divide off the log of b, right? So we divide both sides by the log of b. And I get that y equals this, right? But didn't y equal this in the beginning? Isn't this y the same as this y? And if y equals this and y equals this, then this, by the transitive property of everything, these guys have to equal each other. Neato, right? Now, I want to make sure we read this carefully. With an equal sign here, is this saying that the common log is the same thing as the natural log? You might think that, and I could understand why. What this is saying is the ratio of the common logs here is the same as the ratio of the natural logs here. But the common log by itself is different than the natural log. Those are different functions, different bases. Okay? All right, if you want to verify this. Oh, so why does this work for natural logs as well? Well, why did it work for common logs? Does anyone remember the trick? Right here. I just took the common log of both sides. What if instead of taking the common log of both sides, I took the natural log of both sides? Then everything is natural logs instead of common logs, and you end up with that same sort of answer. Okay?